Cat channel. Please do remember, subscribe, like and share. Thank you. Now we proceed with acid-base. First, we do some definition of titration. It's a procedure for the determining of the concentration of solution of unknown concentration by titrating it with a solution of non-concentration. Okay, and then analyte is solution of unknown concentration, titrant solution of non-concentration. Endpoint is a point in the titration when the indicator change color, and equivalent point is a point in the titration when the equivalent amount of acid and base has mixed stoichiometrically, meaning that the equivalent amount of acid and base present exactly neutralize one another. Or we can use this definition: the number of mole of hydrogen ion from acid equal to the number of mole of hydroxide ion from base at the equivalent point. So these are the few terms that you need to be clear in this topic. So again, normally the titrant is in blue red because we already know the concentration of the solution. And conical flux is analyte because concentration of solution inside is unknown. And then we have to put the indicator, for example, phenolphthalein. For the calculation part, right, we have to identify the question. Normally the question will ask before the addition of base or acid, at half equivalent point, at equivalence point, or final volume of the titration. Actually, right, this one have to depend the equation of the neutralization and the volume of the neutralization. So let's check these cases by using one example. In a titration experiment at 25 degrees Celsius, a total of 30 ml of 0.1 molar sodium hydroxide was added dropwise into a conical flux containing 25 ml of 0.1 molar hydrochloric acid. So meaning that the starting point is acid, and then sodium hydroxide is added drop by drop. Show the variation of pH of the solution before the addition of sodium hydroxide, at half equivalent point, at equivalent point, and at final volume of the titration. Final volume meaning that initially there are 25 ml. Final means after 30 ml of sodium hydroxide is added, meaning that the final volume is 55 ml. Sketch a graph of pH against the volume of sodium hydroxide. So how are we going to solve this problem? Let's check. First, I encourage students write down the equation. So for this one, right, is 1 hydrochloric acid react with 1 mole of sodium hydroxide, produce 1 mole of sodium chloride and water, 1 mole of water. Why I write the 1 over here? Because, right, in this case, we know the ratio of the acid and the base is 1 to 1. Before the addition of sodium hydroxide means inside the conical flux only have acid, 25 ml of 0.1 molar acid. So the concentration of the acid is 0.1. We straight away pH equal to negative log concentration H plus, and then substitute 0.1, then we get pH equal to 1. So the starting pH for this reaction is pH equal to 1. Always remember at the beginning of the titration, the pH has a low value, indicating that there is high concentration of hydronium ion or hydrogen ion, which is completely dissociated from the strong acid. In this case, it's HCl. At half equivalent. At half equivalent, we always refer to the volume of the acid, the initial. Okay, initial, the volume is 25 ml of 0.1 molar HCl. Half equivalent point means 12.5. So we need to calculate the mole by using mv per thousand. 12.5 times 0.1 is 1.25 times 10 to the power of negative 3 mole. So initial mole for each of the solution, HCl is 2.5 because 25 times 0.1 divided by 1000. And then sodium hydroxide is 1.25. Sodium chloride and water, nothing. So this is the limiting reactant. So we minus 1.25, 1.25, and then here plus 1.25. So over here, okay, HCl is referred to the concentration of H plus ion. So the pH is equal to negative log. Okay, what is the concentration now? We have to find out the mole here, 1.25, and then what is the volume? Half 12.5 from the base, and then 25 from the acid, so total is 37.5. Always remember, concentration volume must be in liter, so you will get 0.033 molar. Then negative log the concentration, you will get pH equal to 1.5. Must always check for the equation. So the number of mole over the acid and the base is 1 to 1. Equivalent point, the mole of sodium hydroxide neutralize exactly with the number of mole of acid. So according to this equation, so the number of mole of acid is 25 times 0.1, and then for sodium hydroxide react exactly is 25 times 0.1 as well. So meaning that there is no final mole for both acid and base. So the amount of acid and base present exactly neutralize one another. So in this case, water. The dissociation of the water is H plus ion plus hydroxide ion. So Kw equal to concentration H plus times concentration of hydroxide equal to 1 times 10 to the power of negative 14. So actually, right, the concentration of H plus is equal to the concentration of hydroxide. In this case, is 1 times 10 to the power of negative 7. If pH, we just negative log the concentration of this one, then we will get pH equal to 7 at equivalent point. Final volume of the titration. Okay, the total volume for the acid is 25, and then the total volume for the sodium is 30. So total volume for the whole reaction is 55 ml. Okay, and then we need to check for the number of mole. Okay, so in this case, hydrochloric acid is 100% react with sodium hydroxide, which is 2.5 times 10 to the power of negative 3 mole. But for this case, right, okay, there are excess of number of mole of sodium hydroxide. So it's 3 minus 2.5, so equal to 0.5 times 10 to the power of negative 3. So now we are using mole over volume in order to find the concentration of hydroxide. So in this case, it's POH because the excess is hydroxide. So POH equal to 2.04. So pH equal to 14 minus 2.04. The answer is 11.96. Always must remember after equivalent point, the pH rise slowly indicate that the concentration of hydroxide ion in excess due to the complete dissociation of the strong base. Sketch the graph. So make sure first titer, number 2 axis, y-axis for the pH, and then x-axis for the volume of sodium hydroxide added in ml. And then next is about the point. Starting point is start from 1, and then half equivalent point 1.5, at equivalent point 7, and then final is near to 12. Then we plot the graph. Always remember, you look at here. This is have to plot a stiff curve over here. And then don't forget after point 1, 2, 3 is about the point. And then 4 you have to plot the graph in a correct method. And then 5 you have to label for the equivalent point pH equal to 7. So this is the diagram from the lecture notes. So this is strong acid versus strong base. So always remember, here must be a stiff curve over here, and then the equivalent point is pH equal to 7. Okay, that's all for this presentation. Thank you. That's all for this video. Please do remember, subscribe, like, and share. If you have any question, please don't hesitate to consult with your lecturers. Stay at home, stay safe. Bye.